Hello and good evening, everyone. So I'm Takshila Tilakanayaka, and I will be conducting your 5 days workshop, image processing 5 days workshop. And I welcome you all to the workshop. So we have a like 5-day journey, and within this 5 days, we are going to cover the fundamentals of image processing and computer vision. And so if you don't have any knowledge on image processing, or if you are like an intermediate level one, I mean, if you have the basic knowledge on image processing, or if you are not aware about image processing, that's also fine, since we are going to cover everything from very basics, right? So we have, I think you saw our content, right? So we'll complete the content as we mentioned in the schedule, right? So I will show that again to you. So I welcome you all again. And if you have any issues, any doubts, right? So if you need any clarification, right? You can always ask. What you can do is you can use the chat, right? You can use the chat and you can ask any issue if you have, right? So if you can't use the chat, you can also unmute yourself and ask questions if you have any. And also, so I would like this to be an interactive workshop where you always can ask me questions and get the issues clarified, right? And the other thing is, I will show you the content, right? So this is the content that we are going to cover. So today, the core image processing and point processing. So this is the topic that we are going to cover today. And under this topic, we have many subtopics as well, right? And also we are going to do a project as well. So each day, right? Each day we have subtopics and also the major topic, and also we are doing a project, right? So since this is the first day, sometimes we won't be able to do the project today itself, right? But after completing the sections, right, we will do the, right, so we will be able to do the project next, I mean tomorrow, right? So probably we won't be able to do the first practical today, the first project today, but anyway it will be done tomorrow. And the other projects and all the contents that we have, I have shown you in this schedule, and also the plan. We are going to cover them within these 5 days, right? Got it? So as I mentioned earlier, no need to have the basic knowledge. We are going to cover everything from very basics, right? And I hope that you got this tutorial, the fundamentals of Python, and the modules tutorial. I hope you got it, right? Right. So you already, did you watch the Python basics and the Python modules tutorial earlier? Did you? The Python modules and the tutorial, and the Python modules and the Python programming basic tutorial. I hope you got it, right? Did you watch it? Okay. Right. So I distributed it earlier. Okay. Okay, so there is a small delay from the coordinator, right? So I hope that they are the Python basic tutorial and the Python modules tutorial was not distributed among yourself, right? So you will get that tutorial today, right? And please go through that basic tutorial and try to cover them since they will be required for doing this module, right? Okay. Okay, right. Then, yeah. So that's how we are going to do it. And we have 5 days. So 5 days will be going like now. The first day is today, and Thursday, tomorrow, and Friday, we are going to do the sessions, right? So 3 days for the on this week, and the next 2 days, right? Day 4 and day 5, we are going to cover it on next week, Monday and Tuesday, right? So that's how the 5 days will be conducted, right? Okay. So so shall we like have a kind of basic discussion and see what about yourself, and are you familiar with image processing, or have you done Python programming earlier? So anyone haven't done Python programming earlier? Did you work with Python and like familiar with the basics of Python? Anyone? So anyone who are not familiar with Python? Is there anyone? Okay, so seems everyone. Okay, right, good. So I think most of you are like familiar with Python, but if you are not familiar with Python, it's also fine, since I'm going to provide you a basic Python tutorial as well as a Python modules tutorial. So you can go through them and you can cover it, right? Uh, I will provide this basic tutorial, but the other thing is it's totally fine if you are new to image processing, right? So that's not a problem, since we are going to cover everything from very basics, right? So don't uh, get nervous. We are going to cover everything from very basic. So it's fine to be like fine to be a beginner in image processing, right? Since we are going to cover everything. So we have, as I mentioned, we have some interesting projects that we are going to complete through in these 5 days, right? So the first one is like coin detection and recognition, and the second one is plant height detection in the greenhouse, and third one is lane detection for self-driving cars, and the fourth one is vehicle detection and counting system, and the fifth one is object detector for building your own object detector using machine learning. So we are going to cover up some machine learning parts as well in this workshop, right? Okay, so we are going to now start, right? So we are going to go from the very basics, and I'm going to introduce you to the image processing, the basics of image processing. But before going on to that, I would like to ask you if you have any doubt, or if you need anything that you need to get clarified about this workshop, you can ask them now before starting the workshop, right? So anything that you need to ask, or anything that you need to get clarified? Okay, so seems not right. Okay, so we are going to now start and go through the section. So I hope you receive these materials, right? The materials, I hope that you received it, right? The workshop materials, did you? Yeah, okay, so I hope you got the materials. So, right, so I think, let me, right, so this is the set of materials that we are going to use. I will show them quickly, right? Um, okay, Okay, so these are the materials that we are going to use in this workshop, right? So we have the day 5 materials, right? So today you need to download this folder, right? The day 1 folder, and in the day 1 folder, you have the IPython notebook file, right? This IPython notebook file, and also there is a folder called the samples, right? So the samples folder contains like materials, I mean, like images and videos that we are going to use in this workshop as samples, and this we are going to take them, take these materials as examples in our codes, right? So these are the two things that you need to have today, right? So you have to download them, and in this workshop, we are going to basically for our coding, I mean, to implement our codes that we are, I mean, in order to do projects, right? So in order to do projects, we are going to use Python program, as you already know, right? And also other than that, we are going to use these set of tools, right? We are going to use these set of tools. Let me show you. We will be using Python programming language, right, as you already know. And also we are going to use this Jupyter notebook, right? So this Jupyter notebook is the development environment that we are going to use. That means we are going to code using this Jupyter notebook, right? But if you are familiar with any other, like, or if you are like familiar with any other development environment, like let's say PyCharm, right, or Visual Studio, right, Visual Studio Code or Python idle. So if you are already working on, and if you are familiar with any other development environment for Python, that's fine, right? That's fine. You can go with that. But officially, I mean, in this workshop, what I'm using is Jupyter notebook. So I suggest you to use this, since like it will be easy for you if you use the Jupyter notebook for your coding, right? And also other than that, we are going to use these libraries, I mean modules in Python, right? NumPy, Matplotlib, OpenCV, scikit-learn. So these are the modules that we are going to use in our 5 days workshop. I mean, modules in the sense libraries, Python libraries, right? So this NumPy is a Python library, external third-party library, where we are going to use for matrix operations, right? Matrix operations. So when you are dealing with, I mean, image processing, there are many matrix operations we have to do. So therefore, for that purpose, we are going to use this NumPy library, and also the Matplotlib. Like sometimes we have to plot graphs, right? 2D graphs, 3D graphs, and histograms. Likewise, we have to plot graphs. So for that kind of applications, we are going to use the Matplotlib library. And also our main library is the OpenCV library. So this is our main library, and this is the Open Computer Vision library, which is a well-known and also commonly used Python library or Python module, we can say, available for image processing applications, right? So it's OpenCV. And also other than that, we have this scikit-learn library. So in the last day, we are going to discuss about how we can combine image processing and machine learning together, and how we can create a object detector, our own object detector. And in order to do that, we are going to use this scikit-learn library. So this library is a well-known library available for Python, and this library is provided by Google. And this library is basically for machine learning applications, AI-based applications. So if you are implementing AI-based, machine learning-based applications in Python, so this is a very helpful library, and this is provided by Google, and it's an open source library, right? So our main library will be this OpenCV, right? So this OpenCV library, we are going to use it for the image processing applications, right? So that's our main library that we are going to focus on this course, right? Okay. So I hope that, right, so you have a development environment, but if you don't have a development environment, right, if you don't have the development environment Jupyter Notebook, you can download it, right? So how we are going to download it? You can simply go to, right, so you can simply go to the Anaconda. You can search for Anaconda download, right? Anaconda download, right? Search Anaconda download in Google, and you will be redirected. I mean, you will get these results, and the first result you can open it, and then you will be redirected to this kind of a page, right? So it's just like you have to select now if you are in Windows, and there are other, like if you are not on Windows, like if you are using a MacBook, or if you are using a Linux OS, right? So you can, the other versions are also available, right? So what you can do is you can go here and download them. But if you are using Anaconda, what you can, I mean, sorry, you can, if you are using Windows, you can directly download it from here, and you will get like the software will be downloaded. It's around like 500 megabytes, right? So you have to just download it and install it, right? So here you can download it and just install it. So it will install it for you. Like it will take like around 1 hour to get it installed. So after that, you can use this Anaconda for coding, right? So what is Anaconda? Anaconda is like what you can do after installing it by like using the methods that I mentioned, right? So you can go to that Anaconda download and then press this button. So the setup will be downloaded. The exe by the executable setup will be downloaded, and then you have to just install it, right? After installing it, now, I mean, like following the normal procedure, you have to install it. And after installing it, then how you are going to open this Anaconda, or how you are going to open this Jupyter Notebook, right? You can first go to the start menu and type Anaconda, right? Then when you type Anaconda in the start menu, you will get this Anaconda Navigator, right? Anaconda Navigator, and you can press on it, and within couple of seconds, you are going to see the Anaconda Navigator in your screen, right? So it will take a few seconds, right? Right. So right. So then you are going to get this window, right? So this Anaconda Navigator, or this Anaconda is a set of development environments, right? So this Anaconda distribution, it provides us set of development environments. Now this Anaconda like Navigator is consist of many development environments which are like developed for data science applications, right? Right. So data science applications. So we have like Data Law, IBM Watson Studio, Jupyter Lab, Jupyter Notebook, PowerShell, Bluewiz, Spider, Qt Console, like R Studio, right? And like there are many other development environments. So these are like especially designed development environments available for data science applications, data science based, AI based image processing, like machine learning, deep learning. So those kind of application based development environment especially designed for those data science related applications, right? So we have many. So what we are going to use is this Jupyter Notebook, right? So this Jupyter Notebook is the one we are using in this workshop. This is a web based development environment, very helpful and very easy to use development environment that we can use it when we are going to code in Python, right? So no need to, you can open the Jupyter notebook from here as well, right? Here as well. Or else what you can do, you can directly open the Jupyter notebook. What you have to do is you have to go to the Jupyter, you can type Jupyter in your start menu. Then this will be suggested like Jupyter notebook. Type Jupyter in the start menu and you are going to get it, and press enter. That will open the Jupyter notebook for you. Now, Jupyter notebook is like, as I mentioned, it's a web-based development environment. So you are going to see something like this open in your web browser, right? Then what you have to do, you can go to the the location from here, right? Now I have downloaded, so let's assume that I have downloaded my like the day one materials here, right? So the day one materials they are in my the desktop, right? So from the Google link that I have provided to you, you have assume that you have downloaded that day one material. So this is what you have, right? I mean, you won't have all of these things, but I think, yeah, let me get rid of the other things. So this is what you should have, right? Right. So this is what you should have, and right. Yeah. So this is what you have. I no need to have the PDF file, but you have to have these other files, right? So then how we are going to open it now? This is in desktop and day one. So this is our code now. Code in the sense, actually, this is not a code. This is a notebook, right? Notebook in the sense, like it contains the codes. It contains codes, and it contains like my lecture slides, the materials, the notes, images, and everything. I have included it in this notebook, right? So you can't open this like by double clicking, or you can't open it using any other software, right? So in order to open this IPython notebook, APYNB, IPython notebook, you have to use the Jupyter notebook, right? So how we are going to open this? What we have to do? Very simple, right? As I mentioned, you cannot open this using any other software, right? So you have to use Jupyter notebook for this, right? So you can type Jupyter notebook in the start menu, and it will open the Jupyter notebook for you, right? So first, it will be open like a web browser, right? So web-based application like this. What you can do then, you have to go to your location. Like I'm going to go to desktop, and in the desktop I have this folder, the day one folder. This is where my codes and everything is saved. So I'm going to go there, and then what you have to do, you have to click on it. So it will open the Jupyter notebook file for you, right? So this is the code, and this is the notebook, and the materials that I'm going to discuss today, all of them are included here, right? So I just explained you about like the Jupyter notebook, how to get it installed. Now you don't have to install Jupyter notebook separately. What you have to do is you have to download Anaconda and install. As I mentioned earlier, as I shown you earlier, you have to download Anaconda and install it, right? So when you install Anaconda, what happens is the Jupyter notebook will also get installed, right? It will also get installed. So with the Jupyter, with the Anaconda, you are going to install, right? Understood? So I just explained you how to install the Anaconda and how to install, how to get the Jupyter notebook open, and from that, how to open these IPython notebooks, right? So each and every day I have IPython notebook. That's where I have included all the codes and all the materials and all the lecture notes, everything. I have included it in this Jupyter notebook. So you have to open it first, right? Using the Jupyter notebook. And the other thing, right? So if you are not familiar with Jupyter notebook, or if you are not familiar with Anaconda, as I mentioned, you can like do the coding using any other development environment. It's fine, right? It's fine. Like PyCharm or Python Idle or Visual Studio, any other development environment you can use. But like if you are interested, and I recommend you to use Jupyter notebook in this workshop, right? So therefore, what you are going to do, right? So what you have to do, like the coordinator, right? The workshop coordinator will provide you the set of, he will provide you set of videos, right? So those videos contain two main parts, right? Consist of two main parts. The first part is Python programming basics. So they are pre-recorded video series, right? So there are two main parts. The first part is about Python programming basics, right? So that tutorial covers the basics of Python, right? So the Python basics required for this workshop, right? Not all the Python, not all the concepts, but the concepts and the basically the basic Python programming content that you need to know, right, in order to cover this workshop. So the first part of that video series will contain the Python programming basic tutorial, and the second part, right, the second part is about Python modules, right? That means Python libraries, how we can handle Python libraries likewise. So that the second video tutorial, that part will be covered, right? So I recommend you, right, I suggest you to go through those set of videos and you will get those material today itself, right? So I will ask the coordinator again to send it to you, right? So you can get them and you can go through them, right? So I assume, like, I hope that you will go through them soon. So like, if you have the basic Python knowledge, don't think that the tutorial won't be like helpful for you. No, it will. So though you have the Python programming basics, I suggest you to go through those tutorials. So it will like basically refresh your memory, right? So that's good for you. So right, so when you get those tutorials, please go through this tutorial. So that the first video of that tutorial, right? So that's what I wanted to say. The first video of the Python programming basic tutorial explain in detail how you can download the Anaconda Navigator into your computer and install it and get Anaconda installed, and also like how you can access Jupyter Notebook and how you can like create Jupyter Notebook files and how you can like basically write codes in Jupyter Notebook and how you can save it. Likewise, all the details will be explained about Jupyter Notebook and the application of Jupyter Notebook and how we are going to use Jupyter Notebook in this video, right? So that video will be the first video available under the Python programming basics tutorial I just explained, right? So today itself, you are going to receive those two set of videos, right? The Python programming basic tutorial and the Python modules tutorial. So please go through them, right? So then you can get the basic knowledge about Python and Python libraries, as well as how to configure the Jupyter Notebook, how to work on the Jupyter Notebook, how to use the Jupyter Notebook, right? Okay, so without further ado, right, so what I'm going to do is, now I assume that you have the like the fundamental knowledge how we can set up our Jupyter Notebook. If not, you can watch that video I just explained, right? And I assume that you have the fundamental knowledge of Python, the basic programming knowledge and the basic knowledge of Python. So assuming that, what I'm going to do now, I'm going to start the workshop and get into the content. So today, as I mentioned earlier, our main topic will be the core image processing and point processing. So we will first discuss about the basic, right? And also most probably we won't be able to do the first project today, but it will be done on tomorrow, right? But we will try to get cover the most of the content today itself, right? Anyway, all the like the topics and all the content that I have given here, right, will be covered within these 5 days, right? So that will be definitely covered. But since it's the first day, like we took like half an hour in order to get our environment created, right? Like to get the introduction. So therefore, sometimes we won't be able to cover this, but definitely it will be covered tomorrow, right? So don't worry. Will you cover machine learning concepts? Yes. The thing is, in our 5-day, day 5, right? So we are going to cover like the machine learning. We are going to get the introduction to machine learning. And also we are developing our first machine learning, the object detection algorithm using image processing and machine learning concepts. So we are going to get the introduction to machine learning. But the other thing is, we have a separate workshop coming, right, for machine learning. In that machine learning workshop, we are going to cover like the concepts in detail, right? Like this is the image processing workshop. But we have a separate machine learning workshop where we are going to cover like machine learning, specifically machine learning, and where we are going to cover all the theories from very beginning. But also in this course also, we are going to get an introduction and we are going to use machine learning, right? In the day number 5. But keep that thing in mind. You have a separate workshop as well for machine learning, which will be start on most probably in February, right? Okay, got you. I hope you got the idea, right? Okay, so then we will go to the today's section, right? Okay, now we are going to get the introduction to image processing, right? Image processing. Let me turn on the. So I will zoom the screen a bit, right? So the same window, I'm going to like zoom it so you can clearly see in the content in this notebook, right? Okay, so this is the same one. I just zoom it in, right? Okay, so image processing, that's what our workshop is about. So these 5 days we are going to cover the image processing concept from very basics to the advanced concept, right? So we are going to go from very basics to advanced concepts. But before going into that, so we are dealing with image processing. That's what our workshop is about. But we have to, like, before processing an image, we need to know what is an image first, right? What is an image, right? So image is, as you can see in the first figure, right? So image is, right? What? It's a set of pixels, right? So I'm talking about a digital image. I'm not talking about image or a photo, like a real photo, right? Not a printed photo or not a wallpaper, right? I'm not discussing about them. I'm discussing about, like, I'm explaining about digital images, right? So when you have a digital image is a set of, like, it can be identified as a set of pixels, right? So what do you mean by a pixel, right? Now, all the digital images are made out of pixels, right? So what do you mean by a pixel? Any idea? Right? Any idea? A pixel. Yes. So a pixel is simply, we can say, right, the smallest element, right? A smallest element in the image, right? A smallest element in the image, right? Which has a single color, right? So what did I say? Okay, so I'm telling you that, okay, a pixel is the smallest element in an image, right? And it has a single color, right? Yes, that's true, right? So now I will ask you a question. Now, this is not related directly to this topic, but can you identify what it is, right? So what this image, right? So can you identify what it is? Any idea? So what is the object? So what's the object in this image? Yes, any idea? Quickly. Yeah, it's kind of a blur image, but can you identify what it is there? Yes, very good. So it's a human face, right? So we can say now, the thing is, it's a like a very blurred, low resolution image. Low resolution in the sense, like, it's like made out of low amount of pixels. So that's why you call it low resolution, right? So if you have very high number of, very like large amount of pixels, it's called a high resolution image, right? Right. Now, since like here, even we can count the number of pixels, like 1, 2, 3, 4, 5, 6, 7, 8. Likewise, we can count the number of pixels. So around like 400 pixels are there, as I can see, right? No, not 400. 1, 2, 3, 4, 5, 6, right? So two are like, let's say, okay, 12 and 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so almost like 300 pixels, let's say, around 300 pixels are there, right? Around 300 pixels. Might be wrong, but pixels are there, right? So you can see like pixels. You can see the small, right, elements, the square shape elements, right? Square shape elements, and you can see clearly that a pixel contains a single color, right? So it's a pixel has no any mixed colors, but it's a single color, right? So that's what you call a pixel. So we can understand, okay, then a digital image, I'm talking about digital image now. You can't see pixels in like a photo, I mean a real photo, right? You can't see pixels there. So pixels are there in the digital image. So that's you need to understand, right? So pixels are there in a digital image. So this is what you call a pixel, right? So actually, like we can now, why we can understand this image, like, oh, we can say, okay, this is a human face. So we can see that. And the other thing is, to be specific, this is Abraham Lincoln, right? So if you know Abraham Lincoln, now you will see, okay, this is Abraham Lincoln, but like it's quite hard to say, right? Since you can't like clearly see the ears, right? Eyes, like even the beard, right? So nose, mouth. So those features cannot be seen, right? So those features cannot be seen directly. But like you can understand, like it's Abraham Lincoln, you can identify that it's Abraham Lincoln by just looking at like the color combination, like you can see the beard here, right? So likewise, it can be identified as Abraham Lincoln, but it's a very low resolution image, so it can't be directly, I mean, it can't, like, we can't clearly say, okay, it's Abraham Lincoln, but say Abraham Lincoln, right? Anyway, so now we kind of like we can understand this image, like we can describe this image, right? So there is, okay, there are like eyes here, right? So there are eyes and there are this nose, like this is the mouth and this is the beard, likewise, right? So we can like identify, even it's a very low resolution image, we can still identify the features, right? Now how we are going to understand these features, right? For example, now this is the next image. You can see this like apple, right? Apple. So you can identify this is apple, right? How we are going to identify? Huh? So how did you identify it? Since you can see color, right? So you can see color and the color variation, the color difference, and you can, due to this color difference, you can identify it. Okay, so this is like yellow. Okay, this is yellow, and like you can identify it as a leaf, and this is kind of red, and due to this red color, and you can identify the shape as well. So according to the shape and the color, you can conclude, okay, this is apple, right? This is apple, you can conclude it, right? And so this is the tree, right? And also this is the background, so you can understand, like, so everything, like you decided it not exactly from the color but the pixels, right? So pixel values, right? That means we can identify these colors, right? So from this color combination, I mean the color variation, we can identify the background, we can identify the fruit, I mean the apple, and we can identify the leaf and everything we can identify, right? So similarly here we can, okay, identify the eye here and the nose here and the mouth here and the beard here, likewise we can identify them, right? Got it? So that means we can understand the color, the pixel values, we can understand it, we can describe, okay, right? But the thing is, right, in a computer, right, the computer cannot see, like the computer is not going to understand colors, right? So what it will see, right, computers, they are going to store images, like in form of numbers, right? So they are going to use numbers to these pixels, and they are going to assign numbers, and they are going to like store the image, right? So basically now all the images that you are going, like in your computer, you have images, right? So those images are like basically, right, you have saved those in your computer, and like those are saved like in terms of this kind of set of numbers. To be specific, they are saved as matrices, so arrays, we can say simply, right? So that means these values are the pixel values, right? So basically these are pixel values, right? These are the, like, I mean, each and every pixel is represented from a number, right? I mean, we can see a pixel from the color. Yeah, we are going to identify pixels from the color, but actually in computers, no, I mean, the computer can't sense colors, it can sense numbers, right? So what will happen, the image, the pixels, they will be stored as numbers. Understood? So you are going to see a set of numbers, right? So you are going to see a set of numbers like this. Understood? Right? Now, if I ask you, okay, now can you understand what this image is about? Why? The computer sees set of numbers. Computer is not going to see the pixel color or right anything. The pixel will be represented by a number, right? So this is represented by number, this is represented by number, this is represented by number. Likewise, all the pixels are represented by numbers, right? So now, for example, if I ask you, okay, what this image, right? So can you identify what is in this image, right? So probably you can't, right? So you can't see eyes here. Can you see eyes, right? Can you see eyes? Can you see nose here? Can you see the mouth here? Can you see the beard here, right? So can you see it? No, you can't see. Why? Like we are not learned to identify features from numbers. We have trained to identify features, I mean this object, from color, like pixel, I mean the color, right? Exactly. But computers see these set of numbers, right? Computers are going to see these set of numbers, right? Now, you probably have seen like image processing applications, like there are many image processing applications, right? That we can, right? That we can, we have seen probably, right? We have seen many like image processing applications. Now, let me show you some examples that we can do using image processing. So then you are going to get an idea. Some of these examples will be done in our workshop as well. But first of all, let me show you some examples, right? Some of these examples, we are going to try them in our workshop as well. So, right? So this is a simple, right? Right. So this is something that we are going to do in our workshop. Let me, right. So this is something that we are going to discuss in our workshop, right? So you can see the first one is about like, so this is something, sorry, there is a, what is this white? Yeah. That's what I'm trying to figure out. Anyway, give me a second. I will sort it out. Right now, probably you will see it. Okay. So this is a, so again, there's a white. Why this white? What is this white? Um, give me a second. Ah, right. So this white screen is drawn by me again. Sorry, that's something that I. Okay, so that's what I drawn earlier. Sorry. Okay. Anyway, so what I was discussing. Let me get back the screen. Right. Sorry about the delay. Right. Okay. Back again. So now this is one application that we can. Okay. So now this is a project that we did. We can do for a greenhouse, let's say, right? So instead of going inside the greenhouse and measure, like, let's say now in greenhouses, in some applications, they have to control the carbon dioxide levels, water levels, humidity levels. So they have to control in order like grow them properly, grow plants properly, right? So in order to do that, like they are going to constantly measure the height and the like the growth, for example, the growth of plants, right? So instead of going inside the greenhouse every day and measuring the heights or the growth, what we can do is like we can use a camera, and using a camera we can measure the height, right? So that's what we can do. So this is a very simple project that we can do in image processing, right? So this kind of example we are going to explain in our workshop, right? So the plant height detection, we will do it in our class, right? Got it? So this is one application, like basic application we can do from image processing, the basic image processing. And also right, so this is again another application that we are going to discuss on the 4th day of our workshop, right? So this is a vehicle counter. To be specific, we are counting the number of bikes here, number of bikes passing this line, right? So this is another application that we are going to use image processing here, right? Got it? So this is brain tumor segmentation, right? So this will be also discussed briefly in this class, right? Brain tumor detection and segmentation, right? So likewise, we have many applications that, like, this is object detection, right? So we are going to discuss how the object detection is done in our workshop, right? Object detection, how we are going to discuss how it's done, basically, right? Likewise, we have many examples that we can think of, right? So these, all of the examples that I showed, right? So they are not like industry level applications, but like very simple applications that we are going to discuss in our workshop, right? That we are going to discuss in our workshop within this 5 days, right? So they are like, you can see like, okay, they are small applications, but we are going to learn how to do them, right? So that's a big task, right? Though they are very simple applications, I mean, it seems simple, but it's not. So we are going to learn how we can do them in our workshop, right? But the thing is, now in order to do that, like it should be done using a program. Now we are going to do all of these things using a program, right? So you have to keep that thing in your mind. So you are going to use a Python program, and we are going to detect objects, and we are going to measure the plant heights, and we are going to do all the stuff using a program, a code, right? So that means we have to process these images, right? So when you have images, we are going to process them and detect objects, measure the height, right? And detect the brain tumor, right? Likewise, we are going to do lots of things, but in order to do that, we have to take this image and we have to process it and detect the objects and everything. We are going to do it like after processing the image. So that's what image processing is about. So we are going to take an image and we are going to process it, and we are going to detect objects, right? We are going to measure height, we are going to detect the brain tumor, right? Likewise, we are going to do many applications. So that's what image processing is about. I hope you got the idea what is image processing, right? Got it? Now, the other thing is, when you are going to deal with image processing, right? Don't think like images are like this now. The computer is not going to see the images like this. Instead, this image will be seen by the computer like this, right? So it's going to see set of numbers, right? Set of numbers, right? So we can now identify eyes, right? We can identify the nose, we can identify the mouth. Likewise, we can identify things, right? By looking at the pixels, we can do that. But no, the computer is going to see set of numbers, right? So that means we have to perform many operations. Like we have to do some mathematical operations. We have to do like set of operations in order to get the objects detected, get the height measured, get the tumor detected. Likewise, in order to do the processing, we have to do some mathematical operations, right? So that's basically about image processing, right? Hope you got the idea what we are going to do, right? So we are going to play with this set of numbers, these pixels, and we are going to detect objects. We are going to measure heights. We are going to detect tumors, and we are going to do lots of things throughout this workshop, right? Okay, hope you got the idea. Then what we are going to do, right? Now, you know what the image is about, like basically what's a digital image is about, right? So you know that now, right? So you know what's the image. Now we are going to discuss like the main types of images available, right? The main types of images available. Now this is a like a very high level classification. Like we are going to discuss them in very like high level manner, but we can divide images into many other categories, right? We can divide images into many other categories, but like in this course, right? The domain of image processing, right? In the domain of image processing, we can categorize images to three main, right? Actually, there are four, but I'm discussing about the main category. So we have three. Otherwise, we have four categories. I will discuss about the fourth one later. But for now, let's assume that, okay, there are three categories, right? So image, you know that image is simply consist of like pixels, right? So that's you already something that you already know, right? And this pixel, right? So the pixels are there, right? So set of pixels, we can identify it as an image, and according to like the value of this pixel, right? So depending on this pixel value, you can divide the images into three main categories, right? You can divide the image into three main categories. They are color images, gray images, and binary images, right? Color images, gray images, and binary images, right? So what is a color image? In a color image, a single pixel, right? A single pixel contains three values, or we can say a single pixel has three components, right? Single pixel has three components, and like usually the main color space is BGR or RGB. We can say BGR or RGB, right? Right. So that's what you call a color image. Now here you can see there's a color image. So this is a color image, right? So there's color, right? So this pixel, right? If you take a single pixel, right, in this color image, right? So if you are going to take a single pixel, okay, let's say this pixel has three values, right? And they are BGR. So this pixel is this pixel is like we can say this pixel contains three components like BGR, right? So that's what you call a color image. But the thing is, there are many other color spaces available like YUV, HSV, RGB, BGR. Likewise, there are many color spaces, but we are only focusing about BGR here. We will discuss about the other color spaces later. For now, in this example, let's assume, okay, all the color images are BGR images, right? So that means blue, green, red. So technically, we can say any color in this world, right? Any color in this world can be created by combining the blue, green, and blue, green, and red, right? So we have to find, what we have to do is like we have to find the pure blue, pure green, and pure red, and we can mix them, right? Like from the ratios we decide, right? So we can mix them. So what we can do, we can get any color in the world by like mixing them from different ratios, right? So BGR, again, in OpenCV and Python and any digital image, most of the digital images, these BGR components, right? You know that there are three values, and the three values are like 8-bit numbers, right? So that means a single pixel contains three 8-bit numbers, right? Three 8-bit numbers, right? Three 8-bit numbers. So you know that a 8-bit number, right? 3 into 8 bits, right? 3 into 8-bit number. So you know that a single 8-bit number, right? So 8-bit number means you can hold a value. So let's say that you are going to hold only, like it will hold only positive value. So then you can say a 8-bit number can hold a value between 0 to 255, assuming that it can hold only positive values, right? So you can see that we can identify like there are 0 to 255. We can save a number between 0 to 255 in a 8-bit number, right? So that means simply we have 3 values, right? Like we have 3 values in the range of 0 to 255, right? That means, okay, we can mix these 0 to 255. I mean, we can change these 0 to 255 values and get any color in the world, right? So we have 3 8-bit numbers in a color image for a single pixel, right? And what we can do, okay, we have 0 to 255 numbers, we can change the value and we can get any color we want, right? For example, I will show you a demonstration of this, right? Give me a second to go to that. Right. Okay, so you can see, right? So here I'm going like, okay, 255 RGB. Now this is in the terms of RGB, right? So if I put like 255 0 0, that means this is the pure red color, right? Pure red color. And if you put like, okay, 0 255 0, that means this is the pure green color, right? And okay, so this is the pure blue color, right? So what you can do, right? So you can mix these colors. For example, you can mix red and green, right? So this is the yellow color. You know this from, right, your grade 1, grade 2, right, classes. You know that this is basically like the mix of the pure red and pure green. You are going to get yellow, right? Likewise, and if you mix red and blue, what you are going to get, right? So this is right, kind of a purple color, right? So other like what you can do is you can mix any amount you like okay, 120, right, 50 and 78, right? So this is another color, right? So you can mix any amount you like, got it? Any amount you like. So the other thing is like if you like theoretically we say if you can mix like this same amount from red and blue and green, the same amount from red, green and blue, you are going to get the white color, right? So that's the purest color we say, right? And in the other hand, you can get like if you are not going to like put any amount of color from any color component like RGB, so this is the empty color, or we can say black, right? So if you are not going to put any color from RGB, that's the empty color, right? Void, we can say. So that color is black, right? So likewise, this is the color image, right? Basically, so in a single pixel color images, right? In color images, a single pixel contains 3 components. Like, so in a pixel, the color is made out of 3 components like this. Now, what you can do is, right? I mean, you see that you can get any color, right? So a single pixel has 3 components. That's what it says, right? So that's what about color image. So you have like different, right? So now, for example, this pixel value. So let's say this is a pixel. That pixel is made out of mixing 3 R, G, and B values, right? So that's what you have to say, right? Okay. So the second type, I hope you understood now. As I mentioned, this is a interactive session. So if you have any questions, I'm always encourage you to ask them, right? So don't wait until the session is over, right? So you can ask it at the same moment. You can unmute your mic and ask, or else you can just what you can do is you can just use a chat and you can send me the question if you have any, right? So don't hesitate to ask me questions if you have any. Okay, the second one, the second type of image is like the gray image, right? So gray image is simply what a gray image says. It has a single 8-bit number, right? A single 8-bit number, right? Single 8-bit number, not 3, but single 8-bit number. So in a gray image, what happens? No need to like remember this set of values. Like the thing is now, just keep an idea in your uh, head, right? So that's what I need. Otherwise, no need to keep all these values, right? So just keep an idea about this. That's all, right? So gray images, right? In the gray images, what you have, like you have a single 8-bit number. That means you can hold a value between 0 to 255. So this is an example for gray image, right? So gray images can only hold gray values, right? So if your pixel now, that means a single pixel has a single value, right? Not three values, but a single value. And that value can range in between 0 to 255. Why? It's a 8-bit number, right? So it's a 8-bit number, so it can range from 0 to 255. So if your pixel is 0, that means that pixel is pure black, right? If your pixel is 255, that means your image, that particular pixel is pure white, right? But you have a middle value, that means gray, right? That means now don't get it confused, right? So I can't like right yeah, so right, so now don't get confused. I'm putting like the same value for the all the components, right? So like, I mean, since this is RGB, like 255 255 255 means like it's red, right? Now actually there should be a single component, right? A single component. Now no, it's, you have like provide three. Now anyway, like if you put like 150, right? Right, so this is what you call a gray color, right? So when it is closer to, like when it is closer to 0, it's a dark gray color, right? So you can see it's a dark, very dark, right? And also when it is like closer to 255, for example 200, let's say, you can see it's a very light gray color, right? So understood what happens now, right? So that means you have a single 8-bit number, in gray images for each and every pixel, right? So in gray images, each and every pixel is consist of one 8-bit number. So it can have a range between 0 to 255. So if the pixel value is 0, that means black. If the pixel value is 255, that means white, and any other value in between is a gray color. Like, so it's when it is closer to 0, that's a dark gray color. When it's closer to 255, it's a light gray color. Understood, right? Hope you got the idea. Then the third one, like third type of images, basically they are called binary images. Why it's called binary? It has only two colors, no any other options, no any gray colors, either black or white, right? Either black or white, right? So that means that contains only black and white pixels, right? 0 or 1, right? So this is an example, right? So that's called a binary image. You can have only two values, 0 or 1, right? Got it? So that's what we call binary image. And there's a fourth type. We are not going to discuss it in this moment, and we are not going to discuss it in this our course, right? When you have transparent images, you have seen like P and the vector images, right? So the other component is like it has color BGR, and there's another channel called alpha, right? This alpha channel is about the transparency, the transparent amount, right? So that for the transparent images. So that's the fourth type. So we are not going to basically look into that in our workshop. So you just keep that in your mind, right? So no need to worry about that, since we are not going to use the transparent images in this workshop, right? This is a transparent amount, the fourth component, right? That's for the additional knowledge, right? Okay. So now what you know, right? So basically now you know how you can identify images and the basic types of images, right? So that's something that you know at this moment, right? So now what we are going to do, right? Now we are going to do is we are going to now like you use the OpenCV module. Now what do you mean by OpenCV? I discussed this earlier, right? So we know that like I explained this earlier. So we are going to get now the OpenCV library, right? So OpenCV library will be used in our workshop, and this library we are going to use it for our image processing applications, right? So in order to use this, what you have to do is you have to first install this. Like by default, when you install Anaconda or when you install Python, this library won't get installed. This is not a standard library, right? So we have many standard libraries, like in Python, we have many standard libraries like OS, right? And datetime, not datetime, sorry, OS and math, right? So likewise, we have some base libraries. That means with the Python installation, those libraries will be installed, right? But these, like the OpenCV library is not an inbuilt library, right? OpenCV library is not an inbuilt library, so you have to install it separately. It's a third-party library, right? So the OpenCV library, here onwards, we are going to use the OpenCV library. We are going to use the OpenCV library to do our image processing tasks, right? To our image processing tasks. So before using it, you have to install it. So how we are going to install the OpenCV library, and also this is common for other libraries as well, right? Sometimes in our future implementation, we need more libraries, right? So those are not already available already installed in our Anaconda or our Python. It's not already installed. So if you want to, if you want to install a third-party library, it can be OpenCV, it can be scikit-learn, it can be any other library. If you want external library, you have to install it. So how we are going to install it? Very simple process you have to follow. You have to go to the start menu and open the Anaconda prompt, not the Anaconda navigator, the Anaconda prompt, right? So when you open the Anaconda prompt, what you are going to get is you are going to get something like this, right? So this is a command prompt, for example, right? A terminal, right? So here you have to type a very simple command. What's that command? Pip install OpenCV -Python. So this is how we are going to install OpenCV, right? Pip install OpenCV -Python. So this will install the OpenCV library in Anaconda. I mean the Jupyter notebook. It will be installed. So I will share you the command as well, right? So you can just install it, and it's a matter of entering the, type and enter, right? So it will be installed automatically. It's going to download it from the internet, right? So it's going to download it from the internet, and it's going to install it in our computer. So it's automatically done. No need to worry about anything. You have to just type this command, right? So you have to first install it in your computer using the Anaconda prompt in order to use it in your Python code, right? So you have to do that definitely, right? Got it? So any other library now, for example, we have a library called Pillow. So if you want to install that Pillow library, this is how we are going to do it, right? So also any other library, now we have many other libraries like Flask. Let's say there's a library called Flask. So if you want to install Flask, it's pip install Flask, right? So likewise, any library you want, a third-party library, you have to download that, install it. You can do it automatically. The Anaconda will take care of it for you. You have to just type the command, right? So you have to follow it. Now, as I mentioned, now don't get confused, like what's this Anaconda prompt and how these libraries are working, right? So don't get confused. You will receive the Python modules tutorial. Now, can you remember? I told you that there are two main basic tutorials that you need to follow. The first one is about Python fundamentals, right? So that Python fundamentals tutorial, the Python basics tutorial, you will get as the first part. The second part, as mentioned earlier, it's about Python modules, right? So that means how you can simply use a module in Python, and how you can include a Python module, and how you can install a Python module, and how to use them. Likewise, we are going to in detail discuss about them in that set of tutorials. So you will get it today itself. So please go through it and try to get them covered, right? So I just explained how to install it. So you have to just install it, and then you can come back to the code and you can use that library right here. So how we are going to include that library into your code, right? So in order to use the library, now we are going to use OpenCV library for our image processing applications, right? So I explained that earlier as well. So from here onwards, we are going to use this OpenCV library, and we are going to implement codes and we are going to do image processing using this OpenCV library. So in order to do that, first what you have to do is, first you have to include the library into your code. That means you have to import the library into your code, right? So how we are going to do that? It's a very simple process. What you have to do is you have to write the command like import cv2, right? So that's what you are going to write, import cv2. Now if you are not familiar with how to right, how to use this Jupyter notebook, right? So please watch that tutorial, the Python basic tutorial, the first video of the Python basic tutorial, right? So this is basically importing the library, right? Importing the OpenCV library. Now you can put comments in Python using the hash, right? So importing the OpenCV module. So that's what we are going to do. So now why it's called CV2? Now you may have a question, right? Why you call CV2? So the library is OpenCV, right? So why you are going to use CV2? That's because that's the name that given by them, right? The module developers, those who have developed the module, they are going to refer the OpenCV library as CV2, right? CV2. That's why that's the name of the library that we are going to use, right? So that's why it's given, like it's not a custom name, like this is something given by the who build the library. And so we have to use that command. So CV2 is basically the OpenCV module, so importing it to our code, right? So now we have imported the OpenCV module into our code, right? So it could be done simply using import CV2, right? So this is just a command. I hope you know how we are going to put comments in Python, right? So this is a comment. So you have imported the CV2 module. Then what you are going to do? Now you can simply like the first command. Now we have many commands. We have many functions available in OpenCV that we can use it for image processing. But we are not going to discuss everything now. We are going to step by step learn the other functions, other operations, other other functions and operations available in OpenCV, right? The first one to start with, we are going to use the first function, like the one. We are going to learn about the first function in OpenCV that we are going to learn is the imread, right? So there is a function called imread. Using this imread function, what you can do is you can read the already available image from your computer and you can load it to your code, right? You can load it to your code. Now, how we are going to do it? Very simple. CV2 dot. Now, why you call CV2 dot? Now, whenever you are going to use a function, a method available in a library that you are going to import, you have to always put that library name first, then dot. That means cv2.imread. This means, okay, call the cv2 library, sorry, call the, go to cv2 OpenCV library. Now we have already imported it. Then what you have to do, cv2 dot, then import, get the imread function, right? So we are using the imread function available in cv2 OpenCV, right? Can you all give me a minute? I'm getting a call. I will be back in 1 minute. Please give me a minute, right? Okay. Okay, right. So the first function of the OpenCV library, imread. So this imread function is used to read an image from your computer, right? Read the image from your computer. Now I'm here, right? I'm here like I will show you. Okay, I'm in the desktop of my computer, and in my computer I have this day one folder, right? Day one folder. Then uh, day one folder. So in this day one folder, this is my code, right? So this is the code that this is the notebook that I'm discussing with you, right? So this is the Jupyter notebook that I'm discussing with you, right? So what you have to do, right? Now what I'm going to do is, as I mentioned, like we are in the function called imread. So this imread function takes, like this imread function could be used to read the image from your computer, already existing image from your computer, and you can read it and you can get it your code, right? Get it into your code, right? So that's what we are going to do. So in order to do that, you have to provide the path of the image, right? So you have two methods of doing it, right? The path. Now, for example, let's say that you want to open this image, the flower.jpg image, right? So what you have to do, you have to provide the path of this image, right? So you can provide the path in two methods, right? The first method is like you can give the relative path. Relative path in the sense, okay, now your code is here, right? So this is where your code is located. From where your code is located, right? Relative to that code, give the path. Okay, relative to this code, your image is in samples folder, right? From here, it's in the samples folder, and inside the samples folder, it's the flowers.jpg, right? So that's how you are going to provide the relative path. So relative to your code, right? So that means, okay, you are going to provide samples, right? And likewise, you can provide the, okay, flower.jpg, right? So this is the first method of doing it, right? So you can say, okay, the path, right? So you can provide, okay, samples folder. Now, relative to your path, relative in the sense, now your path is here, right? So this is where you are now currently, your code is. So from your code, relative to that, it's in the samples folder, and the this one, flower.jpg. So that's what I have given here, right? So this is the method number one, right? And what you can do is you can take it, right? So this function, the imread function of CV2 library, just read the image that you have provided, like the image, the path, right? The image corresponding to the path that you have provided, that image will be read, and it will be like, what you can do is you can assign it to a object like this, right? So it not need to be image, it can be any name, like you can provide any customized name. This is an identifier, right? So you can provide any name, but in order to make it sense, like I'm going to provide it as image, right? Got it? So then this is like the relative path that I have provided, the relative path, right? So this is the method one, right? So this is something that you can follow, like relative to your location, you can provide the path, right? So the other method is like the absolute path. In order to provide the absolute path, what you have to do, right? You have to go to the, right? So you have the name first, right? So you have the name first, right? Flower dot, or else we will remove that as well. You have to go to the location, right? So where your image is located, right? Okay, so this image that I'm interested is this flower.jpg. So what you are going to do is you are going to get the address from here, right? The address bar, right? Address bar, you can take the address, right? So here you can take the address, and you are going to just take it and take that address and paste it here. And also you have to provide like the flower.jpg, the file name also you have to provide. And the other thing is, the next thing is that like you can see that the slash, right? So it's in the other way when you are going to provide it in the, like it's the relative path, but in this method, since you are copying it from the address bar, it's in this direction. So I mean, it's in this direction. The slash, you can see it's in this direction, right? So like it's into the left side, right? So in order to get rid of that, you can you can like do it manually. You can manually rotate this. I mean, you can manually change it to the other side. That's something that you can do, right? But it takes time and it's not appropriate to do that. So therefore, you can directly put R here, right? So when you put R here, when you include R here, what will happen? It get automatically converted and it converted to a path, right? So anyway, when you provide, so this is called the absolute path. That means no, like it's not relative to any location. We just went to the location and we just got the absolute path, right? So this is the absolute path. So when you provide absolute path, you can copy it from this address bar and paste it, and then make sure that you are going to put a R in front, right? So that's a requirement when you provide the absolute path, right? You have to put a R at the beginning of the path, right? So that's a requirement when you provide the absolute path, and it's not necessary for providing the relative path. When you provide relative path, it's not necessary, but when you provide the absolute path, you have to put the R. Okay. What is R? So this is something for the regular expression. What it's called, it's therefore the regular, converting it to the regular expression, right? So what it means by regular expression, now I will explain it in like very simply. Now usually when you provide a path, what you have to do is you have to put the slash in this side, right? So that means slash, you have to put it in the slash like the right side slash, let's say, right? But when you are going to copy the path from the address bar, right, in Windows, right, in Windows, the slash in the other side, right, it's in the left side slash, right? So it's there, the address bar, there's the left side slash, right? Got it? Got it? So therefore, when you get that slash, right, it will give an error, right? For example, now if you run this one, it will give you an error, right? Got it? So when you put R, right, so what you can do is you can, like, since OpenCV is expecting the slashes in this side, right? So that's what OpenCV expects, right? So you have to convert it manually, right? In order to get rid of this error, you have to convert it manually. So now the error won't be there, right? Now the error won't be given. But thing is, it's quite hard to, and it's time consuming in order to convert this manually to the other slash. So therefore, what we can do, you can just put the R here. So that R do that thing for you. That means it will convert it to the other side, and it will like do that conversion, the slash conversion for you. Simply, you can understand it like that, right? So no need to convert it manually. Understood? Okay. So with that, what we can do, okay, we have now two methods to read the image, right? The first one is providing the relative path, and the second one is providing the absolute path. So you can provide these two methods, any method you like, right? So then what you can do, okay, now the image will be taken, right, into our like the variable name. For example, this is not actually a variable, it's an object, but for example, now let's say it's an image, I mean it's a variable. Now you can see the size of it, like the shape of it, right? Image.shape, right? So when you print image.shape, right, it shows you that, okay, the image is read and the image is taken, imported into this code, and its shape is 361, 480, and 3. So what this means? Any idea? Right? So it means the image that you have loaded, right? So it has 361 rows, right? 361 rows and 480 columns. That means now here you can see here is the 8 by 8, right? So it has 8 rows and it has 8 columns, right? So you can see, right? So additional question now, how many altogether, how many pixels are there? Any idea? So it has 8 rows and 8 columns. So how many pixels are there in this image? I mean, this image. Yeah, exactly. So it has 64 pixels, right? Now, that means here also you can get the image shape. So image shape gives you an idea about like, okay, the resolution of your image, right? How many rows and how many columns. Now, okay, you can understand 361, 480, right? So that's the height and the width of the image. Okay, fine. But what is this 3? Any idea? You know this? Yes. Yes, Z, right? So that's Z basically, but in other words, you can say what like according to the knowledge that you have gained from today's session, the earlier today's session. Yes, this 3 stands for what? Huh? Right? What this 3 stands for? Okay, 361 is the, yeah, exactly, very good. Now, yeah, RGB, very good, RGB, or we can say like the channels, the 3 channels, yes, indeed, right? That means, so simply we can understand it like 2 methods, right? That means, okay, it has 361 rows and 480 columns. And when you take a single pixel, right? So how many pixels altogether, how many pixels are there, right? So the resolution of the image is 360 into 480, right? So that's something you know. Now, if you take that single pixel, right? So we can say, one can say, okay, these 3 pixels, they have 3 channels, like they have 3 components, RGB, right? So a single pixel, you have 3 components. That's why it says, okay, it has 3 components. That's what the number of channels, right? RGB, like it's a color image, that says, right? Technically, we can identify it as this also, right? So it can, like, say we can identify it. Okay, it has RGB, right? So the same thing you can represent. Now this is one method of like one way of interpreting it, right? Like 360, 483, right? You can think of it as this as well, right? So that means okay, you have 3 channels, like that means it's a cube. So you can think it as a cube as well, right? So it has a blue channel, right? Then it has a green channel like this. And finally, it has a red channel, right? So this is another way of interpreting the 360, 483 thing, right? Got it? So that means what? Simply, right? That means, okay, so this has 3 planes, right? This is 361 and this is 480, right? And like it has 3 channels, right? Right? So here, like, okay, this pixel has, I mean, this value has its R component and this channel has its G component and this channel has its B component, right? So we can think it's like a cube as well. So this is another interpretation, right? Got it, right? So both the methods you can interpret it, right? So there's a 2D array, like, so now here, like the 2 interpretations, like this is a 2D array, right? So you can see 2 rows and columns are there. Therefore we can say it's a 2D array. And a single pixel has 3 components. That's something that you can think of. The other interpretation is, right? Okay, so you have 361 into 480, you have 3 channels, right? So it's like a cube, you can think, right? So yeah, the height is 360, width is 480, and the depth is 3, right? So that's another method of interpreting it, right? So anyway, you have to understand it's a color image, that's all, right? So now let me let me ask you a few questions, right? Okay, so I'm going to print something here, right? Okay, so now this image, we can, like, from here onwards, we can treat this image as an array, or we can treat this image as a matrix, right? So we can treat this image as an array, or we can treat this as a matrix, right? For example, now we can treat this as a matrix. Why? Oh, it has 361 rows, 480 columns, and 3 channels, right? So 3, I mean, the Z axis is 3, right? So then what you can do is, okay, so I'm going to print something like this, okay? So I'm going to print image 100, 150, right? So what this means, I'm going to print, okay. So you know that this image, right, is like, right, so you have this image, right? Okay, so like in images, like you know the Cartesian plane, right? So you know the Cartesian plane is something like this, x and y, right? So you know this. You have done this in your school, right? So this is x and this is y. You know this is Cartesian plane, and like if you want 1, I mean 3, 3, 3, 5. So this is how we are going to mark it, right? Got it? But in the image plane, right? I mean, when you take an image, so in an image you are not going to have this kind of a plane. Instead of that, what you are going to have is you are going to have this kind of a plane, right? So you have xy. Yes, you are going to have xy, and but the xy are like this, right? That means like this is 0, and this is 480. Eh? So this was 480. This is 480, and this is 361. Right? So we have the plane, the Cartesian plane, not the Cartesian, but this image plane. We are going to make the dome, I mean the like 0 point here, right? Then we have 480 here and 360 to this side, right? So not this representation, but images are represented like this, right? So we are going to start from here and go down, right? So now here I am printing 100, 150, right? That means I'm going to go to the 100th row, right? And I'm going to go to the 150th column, right? And here you have a particular what? Yes, there is a 100 and 150. So what is this? Here it is a yes. It's a pixel. Yes, right? It is pixel. Got it? So yes, indeed. Now this is like the x-axis and this is the y-axis, right? X-axis and y-axis, right? So y is the height. Right? This is the height, and x is represent the width, right? The height and the width, right? So this is a per pixel. The x-axis should be horizontal as we got height as 480. No. This is a bit confusing. Yes, I didn't mention that. Now let me print again, right? So yeah, right. So this is what you have, right? So this is like if you take in terms of x and y, right? Like this is gives you the idea about height, and this is the width, right? Right. Got it. So if you right, so if you are going to like representing in x and y, right? X and y. So this will be the first one will be the y, right? And the next one is the width is the x coordinate, the x-axis, right? So the first now, like what we are used to, right? What we are used to tell is x and y, right? So you think like, okay, this is x and this is y. No, in images, right? We give the first coordinate as the y coordinate and the next coordinate is the x coordinate, right? So that's something comes in images, right? So the first coordinate will be row, right? Row number means the x, sorry, y. Row means y. Then the column number. So column number is just X, right? So don't get confused with it, right? Okay, got it. So with that, I hope you understood. And also, like now this simply, right? Now what this prints, huh? So what this prints now here? So you are getting the pixel, like the 100 and like 100 row and the 100 150 column, and the pixel value you are going to print it, right? Got it? You are going to print it, right? So in OpenCV, right? On OpenCV, the color, the like the order is not RGB, it's BGR. Right? So now if I ask you, okay, what kind of a color is this? I mean, this pixel has, right? 100 and 150. What color, right? Can you assume, okay, like referring to these numbers, can you guess what the color is, right? Roughly, right? So this color is this pixel has what color, right? Can you guess? Yeah, it's kind of a red, right? Kind of red, like that's a red. Why? The red component is almost 255. That means it has its maximum value. And also there is some blue involved, right? So some blue is mixed. So therefore we can say it's kind of a bluish red and like a dark red. Yes, exactly. That's a dark red, right? Now we'll see that, right? So you'll see that probably, then you will understand. So what I can do now we have, like, you can see that this is an image, right? So I mean, this image is taken as an array, right? This image is taken as an array. You can't exactly see it now, how many values are there, right? So it's not going to print them all, right? So that's why I can't print it and show you, right? So there are many values, right? So see, now here, like these values are, you can see that these are not the all values. So you can see dot, 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 dot are there. That means there are many other values. They have compressed it, right? They have compressed the values and shown, right? So this dot, dot means there are many other values, right? To be exact, how many values are there? Huh? Any idea how many values are there in this image? Yes. How many values are there? Yes. So you have 361, 480 into, right? 3 values, right? So these amount of values are there. So you can't show them all. So that's why it's like shrink them and show, right? Hope you got the idea. Then what we can do simply, right? So we can show this image, right? Show in the sense, not the values, but we can open a window and show it using the program, right? The code, we can use it. So the command, there's another command that we are going to now write. The second command that we are going, the second function that we are going to use in OpenCV, the second one is imshow, right? So read the image, right? So it read the image from the computer, then the imshow shows us the image. So there are 2 parameters that need to pass in order to show the image. First one is the window name. I will explain what the window name is about, right? Then the image that you need to show, right? The image that I need to show is img, right? Then there are, now this command is to show the image, right? Show the image. That's what this image command is about. But in order to do that, we have any other, like we have some other we need to have 2 other codes as well. I will explain what these 2 codes are about, right? So I will explain what these 2 codes are about, but for now, don't worry about these 2 lines. I will explain them I will explain them later. So here, this one, basically it shows you the image, right? So the image that you have already imported into your code using the imread command, this imshow can show it, right? So we'll run it and see what happens. So then you will understand what happened, right? Got it? So now you can see something like this. So the image is shown in a window, right? So now here, can you see the imshow command? I provided like 2 parameters. What are the parameters? I have to provide like string. So this is a string and it's img, right? So it's the, can you see now it's shown here as the window name, right? So you can give any customized name to that window, right? So that's what something that you can do, like if you want, like, okay, figure 1 or whatever, right? So if you change it to that, one will be shown like this, you can see, right? Figure 1. So that's basically the window name, right? So you can see that it's shown in a window, right? It's shown in a window, a separately open window, and that window name is what you have provided here, right? So then this is the image that you need to show, right? So this is the image that you need to show, the image that we need to show, that one that we just imported from the computer, we are going to show that here, right? And these two are quite important. When you show the image, it's necessary in Jupyter Notebook, it's necessary to have these two lines, right? So what this means, cv2.wait key. So this is simply provides a pause, or simply asks the program to wait, right? Wait. So here it's actually waiting until a key is pressed. What? It waits until a key is pressed, right? So I will show it like this now. Okay, so wait until this command, wait until a key is pressed. So this is what this command does, right? Then this one closes all the windows, right, opened by OpenCV, right? So that's what it does, right? So that means simply when you run this one, now let me right? So now it's how it looks like now. Here we have to provide the, now this command waits until the key is pressed, right? And here you can provide the number of milliseconds that it should wait, right? For example, if I provide 3000 is in milliseconds, right? So that means you know that this is 3 seconds, right? So since it is 3 seconds, why we are going to provide it in milliseconds? So this is basically 3 seconds. So what it does, it waits until a key is pressed for 3 milliseconds. And after 3 milliseconds, it's going to close it, right? So let's see. Right, so it waits 3 milliseconds and close it. See again, 1, 2, 3, right? 3 milliseconds and it closes, right? Now, what will happen? Okay, now let me provide 5 milliseconds, right? 5 milliseconds, right? So it takes 5 seconds now and close it. Destroy the windows, right? Now here, destroy all windows is in the sense, now it's not going to close only this window, but if there is any other windows opened by OpenCV, it will close them also, right? Okay. So now what will happen if you, now I told you that this wait until a key is pressed, right? It waits until a key is pressed. So what will happen if I press a key? Can you see? I pressed a key, right? Before 5 milliseconds, I pressed a key. Now see, before 5 seconds, I press a key, right? That means it waits until 5 milliseconds. It waits for 5 milliseconds. But before 5 milliseconds, if I press the key, then it will go here and destroy all windows. Otherwise, right? Otherwise, what will happen? Otherwise, if you press a key, right? Now, this is what happens. It waits for the millisecond number of milliseconds provided here. It will wait for that number of milliseconds and destroy all the windows, right? So if you are not going to press any key, right, throughout the time, throughout the waiting time, then it's going to wait that time and destroy the windows, right? Like if you press a key before the time ends, right, before the 5 milliseconds ends, then whenever at the same moment you are going to press the key, that moment it will destroy all windows, right? For example, now here I'm not going to press anything, so it will wait 5 seconds and closing. Now I'm going to press a key, right? So at the same moment, it's going to close it, right? So now we have a question. What does wait key 1 will do, right? So it will just open and wait 1 millisecond, right? Millisecond, no? So it's 1 millisecond and destroy the window. So you can't even see it, right? So let's see. So can you see, even like you can see like it's open and just closes it. Why 1 millisecond is like we can't see the image, right? Can you see? It just closes, right? So for example, now if you like write 100 milliseconds, so this is 1/10 of a second, right? So let's see. Can you see now? Huh? Got it? So now what happens when you provide 0 here? 0 milliseconds, right? So this 0 seconds, like it makes no sense, right? I mean, okay, wait for 0 millisecond makes no sense. We can't wait for 0 milliseconds, but what this does is, this is going to wait infinitely, right? This is going to wait infinitely, right? So that means, okay, when you run this, okay, it will wait forever, right? It will wait forever. Got it? So it's not going to close, right? But what will happen? You can press a key whenever you like, then it will close, right? Otherwise, it will wait forever. Got it? Understood? Right? Got the idea about this wait key and destroy all windows? Got it? Fine. Right? Okay. Right? So one last thing about this wait key, right? So now usually what happens whenever you press any key, right? So you can press any key, this right? What happens when you're not going to providing value? I'm not sure about that. I think this also that's the same thing, right? So if you're not going to provide anything here, I think that's going to wait like it's the same like providing 0, right? If you are not going to provide anything, that means it's same like providing nothing. Sorry, it's same like providing 0 here, right? Got it? Okay. Okay, right? So hope you got the idea. So it's same as putting 0 here. Then the other thing is, like now it's not going to worry about the key, what the key we press, right? So we can press any key we want, right? It's not going to worry about any key. You can press any key, right? But here, like we have the option to track what's the exact key it's pressed, right? So how we are going to do it? You can get a value from this cvd.wait key, and you can get like the pressed key into a variable. Now you can provide any value. In order to make sense, I'm going to provide it like key, right? So then you provide, like when you are going to get the return of this function, the wait key function, we can take it to this variable key. You can provide any name, like, so no need to worry, you can provide any name. So then what you can do is you can print this value and see what you are going to get, right? For the time being, I'm going to comment out the other prints, right? So now, right, when you now what you're going to do, okay, when we press a key, we can get what the key that we have pressed. We can take it to this key, right? And we are going to then print it here, right? For example, now I'm going to like, okay, I'm going to press escape. Oh, I'm going to press A, right? So when I press A, it shows me 97, right? So shall we do it again? Now when I press another, like, okay, I'm going to press escape. For escape, I'm going to get 27. Why? Huh? So this key is like giving us the ASCII value of the key, right? Not the key, but the ASCII value of the key, right? So you can have a look about the ASCII table, right? Hope you are familiar with the ASCII table, right? And we can, right? So when I press escape, I got 27. Let's see. Here you can see, right? 27 is the escape key, right? Here 27 is the escape key, so that's why we got escape, right? And when I press A, I got 97, right? So it's obvious, right? Here, let me get the axis table here, right? So I'm going to get it as an image here, right? Okay, so you can say, okay, A 97 is A, right? Here, so that's why I got 97 when I press A at the weight key, right? So likewise, it provides you the ASCII key of the ASCII value of the key that you pressed, ASCII value of the key that you pressed, right? So simple as that. Now, why you are telling us this? So why I'm telling this about this ASCII key? What's the relevance? I mean, what's the application? Do we need to use? Do we have to use this key somewhere? Yes, you can use it for many important applications. We will discuss about this later, right? So now, very simple things, right? We have discussed very simple things up to now. How to get the image and how to like access image. I mean, how to access pixel values and how to show it, right? So that's all very simple things we have discussed, right? Now let me show you one other thing, right? Another sample code. I'm going to do something like this. I'm going to get the image as we did earlier. We are going to read the image and I'm going to make the 100 100. I'm going to make it equal to like, okay, let's say 255 and 255, right? And I'm going to make the image, right? So can you explain what will happen here? I'm going to take like image 100 100. So can you remember earlier we printed it, right? We printed it like what we got is like we got a value like this, right? So we got a value like this, right? This is what we got. And now what we are going to do, like 150 we print, but let me print, okay, 100 and 100. Okay, so you are going to get this value, right? A similar value, right? Almost close value. Now my question, what will happen if I do it? Okay, I'm not going to print it, but I'm going to replace it 25 by 255, 255, 255. So any idea what will happen now? Any idea about what's going to happen now? Yes. What will happen to this 100 and 100 pixel? Yes. What will happen to that? Yes, good. We have answers. Let's see. Yeah, pixel will change to white. Very good. That particular pixel, I mean, to be specific, like 100 and 100. So this pixel becomes white, right? So simple as that. And can you see it? Unfortunately, now this is what you have. Can you see it? After this modification, can you see it? But like it's not visible, like it's not clear, but you can see it somewhere here. I can see it, right? See here. If you watch the center of this circle, you can see that there's a white circle, that's a white pixel, right? So that's how a pixel looks like, right? So that pixel is very small. Why? This is a very high resolution image, right? Not exactly that much high, but comparatively high resolution image. So therefore, you are going to see that it has, like, the pixel has become white, right? Right. So I mean, now you may be wondering, okay, why you are going to do this and show us, okay, this pixel becomes white. I wanted to show you that pixels are accessible, right? So we can access them, right? Okay, so if I do something like this, now let's say, okay, I'm going to make like, okay, not 110, sorry, not 100 100. I'm going to take a range, like I'm going to do it like this: 100 to 200 and 100 to 150, right? So you can even give a range like this, right? You can provide a range like this even, right? So what will happen if I run this now, right? So you can see, right? So now you can see what has happened here. Okay, row. Now I told you, right? I told you. Now don't get confused here, right? So this is, let me select another color. Okay, so this is the x-axis and this is the y-axis, I told you, right? So first, when you are going to provide the first range will be taken as what? Huh? The first range that you are going to, the first value that you are going to will be, it will be treated as rows, right? So that means the y-axis. So here you can see, okay, 100 to 200, right? So 100 to 200, it has become like right, white 100 to 200, and in this side, I mean the x-axis 100 to 150. I got it. So that's what has happened here, right? Hope you got the idea, right? Okay. Right. Okay. So then, right. So that's what you need to understand, right? So the pixels are accessible. That means we can access the pixels, right? So the next thing, right? Right. The next thing, right? So we up to now we use like in order to show the images, right? In order to show the images, what we did was we used this imshow command, right? Up to now, this is what we have done. We have used the imshow command, right? So imshow command to show the image. So what it does is it's going to open a separate window, right? It's going to open a separate window and show us the image, right? Got it? But this method has a drawback, right? A disadvantage. What now? In the samples folder, I have provided you a image like this, right? So this image is a very low resolution image. To be exact, the image is Lena 512-2, right? So this is the image. So you can see this is a very low resolution image. To be specific, if I go to the properties and if I see it, so you can see it like it's 26 by 27, right? So you can see the dimensions, like it has 26 by 27 I mean the resolution. So that means like less number of pixels. That means it's a very low resolution image, right? So what will happen, right? So what will happen if you use OpenCV and show this image to show you the example? Let me do that and show you. Okay, I'm going to load it, right, like this, and I'm going to use the commands that we used earlier, right, that we learned earlier, and I'm going to show it like this, right? So if you show it, you can see like that image is shown, but you can't see it clearly, right? I mean, there are methods that we can resize it, and we can make it high resolution, and we can make it a large image. So there are methods, and we can see it, right? I mean, we can resize it, and we can see a resized image. That is possible. But by default, when you show this image, like OpenCV tries to what? OpenCV tries to show it in the same resolution, right? The same resolution it's going to show it, right? So therefore, we have another methods of showing it, right? So now you can see this is like it opens a separate window, and it opens a separate window and show the image in the same resolution, the original resolution of the image, right? But what we can do instead of doing that, right? We have the OpenCV, I mean the matplotlib library, right? So using the matplotlib library also, right? Using the matplotlib library also, we can show the image. So this is how it's done, right? So this is how it's done. So we can get the matplotlib library. And now, what is matplotlib library? Now don't get confused and don't worry, since the matplotlib library will be covered in the modules tutorial that I told you, right? The modules tutorial, I discussed about the module tutorial, and you will get it today. So please go through the module tutorial, and I'm covering that matplotlib, what's matplotlib, and introduction to matplotlib in that tutorial. So please go through that. Anyway, matplotlib, as I mentioned earlier in the beginning, you remember the matplotlib library is used for drawing figures, right? like charts, right? So that's how graphs, right? Charts. So that's the purpose of Matplotlib. And in the Matplotlib, we can show images as well. And there are a few advantages of using Matplotlib in order to show images, right? So there are a few advantages. Anyway, before talking about the advantages, let me show you how you can show that image, right? So what you can do is you have to first import the Matplotlib library's pyplot sub library. So in Matplotlib, there's a sub library called pyplot. You have to import it. So this is how you are going to do it. From Matplotlib, import pyplot as PLT. So this PLT is a custom name that I have given. What that custom name is basically, now if you want to get the OpenCV library, and if you want to now you can see when you use the OpenCV library, right, you have to always provide it like, okay, whenever you are going to use a method in that library, right, whenever you are going to use a function in that library, you have to always call cv2 dot here, cv.timWait, cv.timShow, cv.waitFree, right? Likewise, you have to always call it by cv2, right? So therefore, what we can do is, instead of giving it importing it like cv2, you can give a customized name, like, right? Customized name, you can give a customized name to this library. It's like this: import cv2 as whatever name, right? OpenCV, no, C, right? Okay. Otherwise, we say, okay, mylib. So if you import it like this, now import CV as mylib. Now we have given a custom name for this function. This module. So here onwards, you are not going to use CV2. You are going to use mylib always. So instead of CV2, you have to use mylib, right? That's how, all right, we can use it, right? So very simple application. Now what I wanted to highlight, now here, instead of always using now here what you have to do is you have to always call otherwise pyplot likewise, right? So therefore I'm going to give a customized name like pyplot as PLT. So therefore what you can do is, instead of using pyplot, you can use PLT, right? So that's a custom name given. So now earlier, this is how I this is the first code that I used to show the image using the OpenCV. So what happens was, it shows in a separate window, it shows the image in the same resolution, the original resolution. Instead of using the CV2, what we can do, we can use plt.imshow. Plt.imshow is Matplotlib. There is another function called imshow. Now this imshow function is CV2 imshow. That means OpenCV's imshow, right? So here what I'm going to do is I'm going to use the pyplot imshow, right? So plt.imshow. So when you do it, you have to provide the image, and when you run it, what happened? You are going to see the image like this. Now, what's the advantage? There are two main advantages, right? What are the advantages? The first advantage is you are going to see it like enlarged image, right? So you are going to see it like an enlarged image, right? So no need to we have seen it from the original resolution in OpenCV, but here now it's not. You can get it's enlarged, right? So resized, and it's going to show you that. And also the other thing is, it's shown in the it's shown in the same notebook, right? No any additional window is open, right? No any additional window is open. It shows the image in the notebook, right? So that's another added advantage, right? Got it? Okay, so the next thing that I'm going to discuss, right? So how we can save images. Now we have a question. Let's see. CMap, right? So CMap. The thing is, I think this is not necessary. Let's see. Yeah, that's not necessary. Sorry about that. The CMap is not required here, right? CMap is not required here. I will. I'm not going to discuss about CMap here, right? I'm not going to discuss about CMap here. CMap is anyway not necessary here. But later we will use CMap in our later explanations, later applications. In that applications, I will, and those applications, I will explain what CMap is, right? So please remind me to explain what CMap is. Since CMap is not relevant here, right? I'm not going to discuss it now, right? Okay. But when the CMap is required, I will explain it, right? Okay. So then the other thing is how we can like write images, right? Write images, how we can save images, right? So what you can do simply, right? So you can get the image, right? Using the imread command, you can read the image. Then what you can do is you can do whatever modifications to image. Now here we have like right, 100 to 150 rows, 100 to 250 columns. We have make it BGR, green color, right? So we have made it green color. Then I'm going to write that image, right? So the same image, I'm going to write cv.im, right? Then I'm going to write that. And here you have to provide the path where that, where the new image should be saved, path and the file names, right? So here also you can provide the absolute path or the relative path. Now you are aware about the absolute path and the relative path, so you can provide either. And here I have provided relative path, and make sure that you are going to provide the path as well as the file name that you need to save it as, right? So I'm going to save it as new flower in the samples folder. So when you write it, so you will see in the samples folder that a new file is created called new flower, right? A new flower. So then it's like it has become green, right? So now this is not a like big deal. What I wanted is like I want to show you how an image can be written into like saved into your computer, right? So that's it, right? Otherwise, like even you can do it using Paint, right? Even you can use this kind of a thing using Paint, right? Microsoft Paint software, you can do something like this. So the application is not about the making it a green color. What I wanted to is like how to save it using a code, right? So that's what I wanted to show you, right? So just keep that thing in idea, right? Now the thing is, we are like in the like first day, right? First day we are gathering knowledge, right? We are gathering knowledge. That means we like small sections we are covering, and like tomorrow onwards we are going to directly go into applications like the plant height detection, coins detection. Likewise, we are going to go into different applications from next day onwards, right? So today only like we are covering the fundamentals. So we have a question: does CV2 has any file extension restriction for images? No, exactly. You can like save it as PNG, JPEGs, images. Yeah, those kind of things can be used, but there will be a list, right? OpenCV, right? ImWrite, or else we can say OpenCV supported images, image formats, right? So we will get a list, right? So you will see a list. So these are the list. This is the list that I think these are the set of formats. This is a set of formats that the OpenCV is supported for, like the images for reading and writing, right? Okay, so that's all, right? So then now what we are going to do, we are going to now discuss about videos, right? So up to now, what we did was we just loaded images from computers and we show them, right? So that's what we did. From now onwards, what we are going to do, we are going to see how we can load videos, like already existing videos from our like a computer, right? How we can get videos, already existing videos from our computer, or else how we can access cameras, right? How we can access cameras and get live videos, right? So OpenCV, when you are using OpenCV, you can read videos from many sources, right? So we can access videos from many sources. So you can use, like, you can get videos, and you can open videos, and you can get videos into code using from local files. That means you can get your video files available in your computer, local files, video files, and you can load them. You can load video files already available, or else you can access cameras in the sense you can access web camera, like your computer, if computer has a web camera, you can access it and load the video. Or else you have like or else if you have like like USB cameras, right? So those USB cameras, you can access videos from USB cameras, or even you can access from CCTV cameras, or else you can access from Wi-Fi cameras, right? Wi-Fi cameras, even you can get videos from, right? So I will first, I will first show you how we can get a video from a already existing video file from your computer, right? So in the samples folder, right? Samples folder, I have a video provided, right? So that video is this one, the face video, right? So there's a video called the face video. This face video contains like this is the video, right? So it has faces. So that's a sample video, and you can see that this is the right. So this is the first. I mean, this is the start of the video, right? So this is the first frame of the video, right? So keep that thing in mind, and we have a set of other right faces as well. So this is a video, right? So let's see, right? So let's see how we can open this video, and how we can open this video, and how we can get frames from this video, right? Now, before going on that, I want to show you some example, right? Now, what's a video? Basically, what is a video, right? So video is nothing, but it is set of images, right? That means now when we are recording, right? So let's say that we are recording a video from your, we are recording a video from our camera, mobile phone camera, let's say. So we are going to record a video from our mobile phone camera. So what happens, what the camera, the mobile phone camera actually does, right? It's going to capture images from a high frame rate. Like, for example, 30 FPS, 30 FPS. What do you mean by 30 FPS, right? 30 FPS in the sense, like we are going to like capture 30 frames per second. Frames in the sense we are going to capture images, 30 images per second, right? So that means we are going to like high frame rate, high frequency, we are going to capture images. So your camera is going to work in very high speed, and you are going to the camera is going to capture many frames, like 30 frames per second, for example, right? Then what we are going to do, we are going to bundle them up. They are going to stack them up, right? And we are going to like create a cube, right? Then what will happen if you play them in the same speed, like for, let's say we are going to play them like 30 frames per second, let's say. So what you are going to do, you are going to see continuous frames, right? You are going to see continuous frame. So what will happen? Your eyes will be like, right? Got it? So your eyes, like your brain thinks, right? So brain thinks that this is something continuous, but it's not continuous. Like we are shown, like we are going to view frames, individual images, but in a high frame rate. So we are going to see, our brain is going to think, okay, I'm seeing a continuous kind of a thing, but it's not continuous. We are going to see set of frames in a high frame rate, right? So that's what happens. So this concept is not a novel concept. So this is a very old concept, and this is something manually did in like 1960s, for example. Even even earlier, right? What you call this Disney frame by frame animation. Here, see, let's see. See? Can you see? Now this is not very clear. Yeah, unfortunately, this is not very clear, but right. So this is what happens, right? Right, see? So you are going to see it like a continuous thing, right? So these frames are changed, right? So see? Right? So this is Disney animation, right? So very like 1930, sorry, 1960s, 1938, right? So even 100 years back, right? Almost 100 years back, right? So the same thing applied in like videos in the present, right? So what we are going to do now, from that, I need you to understand that a video is not a video, but it is a set of frames, right? Now, I hope you could understand that. Video is not a kind of a continuous thing. It's set of frames, right? So what we can do, we can read frame by frame, right? So let's see. Now the example one, in this example one, what we are going to do, we are going to get an video, existing video from our computer and video file, and we are going to read one frame from that image, sorry, that video, right? So how we are going to do, first you have to mention what is your video file or the video source. So in order to do that, we have a method called video capture, right? Video capture, and then you have to provide your video files path, right? Video files path. So I'm going to provide this path. Correct? Then what we can do, okay, we are going to assign it to a kind of an object like this. So what now these names are always, you can put your own names, right? So it's not necessary to do a like name, but in order to make it sense, I'm going to use source, right? Otherwise you can make otherwise you can use any name, right? So then what we can do, so our source is now defined, right? So our video source is this face video.mp4. Now what we have to do is we have to now read one frame from it, right? How we are going to read one frame for it is like you have to mention the source, that the object that we are referring now, then dot read. Now this is nothing but like if you use RRR here, this should be RRR dot read, right? It's a custom name, it's the identifier provided by the user. Then this, what this does, this reads a single frame from the source. A single frame. And it returns, this method returns two things, right? This method returns you two things. What? One is it's going to return two things, so we can take them to two variables like A, B, right? Right. So this function returns two things. So if you are new to Python, right? See, in other programming languages, right? In other programming languages, what will happen? In most of the other programming languages, you know that a function can return only a single value, right? A single value. But in Python, it has the ability of returning multiple values, right? So that's something that's a characteristic of Python. So it can return multiple values, right? Got it? So this returns two values, right? So two values in the sense, these two values are basically, now this first value is a Boolean value. We'll discuss about this Boolean value later. Now, for now, I'm going to forget it. This Boolean value, we will discuss about that later, and we will use it in our applications later. this is the frame. This is the actual frame that we want. Now we are more focusing on this frame now, right? The Boolean value, like we will discuss about that Boolean value later. Boolean value in the sense like it provides us true or false, right? It provides us true or false. But this is what actually the frame gives us by A, right? So here now, in order to make sense, I'm going to like it's just two values, but I'm going to provide like two names like return and image, right? So it makes sense. Otherwise, you can have like AB, doesn't matter. But in order to make it sense, I'm going to put like red and image, red and image. I will discuss about red later, as I mentioned. As I told you earlier, we will discuss about red later. But this is what we should be focusing more, the image. So this is the frame that we are going to get. So this is a single frame, right? So now we can treat it as an image. So we can treat it as an image. Why? We have imported a single image, single frame from our video. So now here onwards, this is a normal image. That means whatever you did to show the image, now you can do it here, right? From here onwards, it's a normal image, right? So shall we run it and see? See, the first frame of the video, right? Now, as you can see, now here onwards, nothing happens. Why? We read a single frame here, right? Now you know what to do. If you want now, this command source.read. So this reads one frame from the whatever the source we have provided here, right? So now you should know, right? In order to like continuously read it, what's the modification I need to do here? What's the modification here to be done here? If I want like, okay, read it continuously, right? So very simple thing, yes? Any guesses? Yes, exactly. You can put a loop. Indeed, you can put a loop. So like whatever things you can like put, not all the things, but right. Yeah, let's say we are going to put this thing now there. Or the source initialization not need to be done again and again, right? So this not required to be done again and again, right? So we will keep it outside the loop. Otherwise, you can have infinite loop like this, infinite loop, and you can just, right? Just that's all, right? So let's run it and see. Okay, the video is not playing. I mean, the frames are not continuously played. Any idea why? You know, what's the issue? Wait key, yes. Wait key is 0. That means it waits infinitely after showing the first image. So it shows the first frame and waits infinitely, right? Now, if I press a key, yeah, it moves, see? When I press a key, it moves, see? So any suggestions, right? Yes, what? Huh? Reduce the key, right? Reduce, not increase. I mean, increase in the sense like, okay, let's say, okay, 10 milliseconds, 10 milliseconds or 1 millisecond, right? Now let's see what's happened. Now it seems like playing, but the window is always closing. What's the issue? Not too fast, not too fast. Huh? Why this kind of thing happening? Yes, now the video is playing, but the window is always closing and opening again. That's a straightforward thing, right? Yes, exactly. Very good. Now we have like what we are doing. Now you can read it, right? We show an image, right? It shows an image and wait for 10 milliseconds and close it, close the window and again show it, right? So it always closes and shows, closes, oh, right? So therefore we need to remove this and put it outside the loop. So then probably this will work fine, right? It's too fast, but now it works fine, right? So now can we can we now stop it in the middle? Any method that you need, you can. Okay, I will show you. I will go until the end. Okay, now you are going to end the video with an error. So see, you are going to get an error. So it says like blah 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 blah, and it says emptying function whatever. Right? Yes, very good, right? The thing is, now here, what happens here basically? This goes in a loop, right? And it reads, now this is an infinite loop, right? So you can see that clearly this is an infinite loop, right? So what will happen in the infinite loop? Yes, what happens in the infinite loop? So it runs forever, right? So now this is going to read frames infinitely, I mean, again and again. Now, when the frames are frames are finished, all the frames are like imported, all the frames are read, right? Then no frames to read. So then what happened? This has nothing to show. So when it try to read something, after all the frames are over, all the frames are read, this returns an empty image, right? So it returns an empty image. So when it tries to show the empty image, this says the empty image, like there's an empty image, so it ended up with an error, right? So what will happen, right? After the frames are already finished, again it tries to read the frame, but no frames are given by the source, right? So no frames to be given by the frame. So no frames to be given by the source. So therefore, this will be an empty image. So when it tries to show an empty image, it gives you error, right? So that's where the ret variable comes into play, right? So now I will show you. Now I will reduce the wait key further, and I will show you this ret, the value of the ret, right? So this ret is a Boolean value. It means it's 1 or 0, true or false. This value will be always true. This value will be true when the source, gives you images, right? So when it gives you an image successfully, this ret is true, right? If the frames are over, or if the source is not available, this ret will be false, right? So let's see. Now it's going to provide you true, right? See, for all the frames, it's going to provide you true, right? Now at the end, what happens? At the last frame, I mean, after all the frames are over, it's going to provide you false, right? So then we can keep a track of the video source from this thread, right? Whether the frames are provided or not. So using this thread, what we can do? So read thread becomes false when frames are not available further, right? When the frames are already, all the frames are read, or when the frames are not available anymore, this ret becomes false, right? So we can keep a track of it, and what we can do is, we can now, this is an infinite loop, right? So we can break it. So if ret becomes false, that means when the ret becomes false in the sense, that means all the frames are over, right? Then what will happen? We can break the loop, right? Now the video, like after all the, now you have to do it before the intro, right? Otherwise the error will be there. So when the ret is false, before, I mean, instead of showing it, you are going to break it, right? So the error won't come, right? So let's see. Right, see. Now what happened now? If you want to see the value again, I will print the ret value, right? Right, so see, so it's true, true, true. At the end, it becomes false. it becomes false, you can see, right? So then what happens when it becomes false, right? Right. So this breaks the loop. So break in the sense it go here and destroy all the windows. Right. So that's what happens. And this red, like now, let's say you have like a not available video source. Now, let's say now this kind of a video is not available, right? This kind of a video is not available. So the red, for that kind of a purpose, also the red becomes false. I mean, for that kind of situation, the red becomes false, right? So it says false and breaks the loop, right? Since this kind of a source, this kind of a video is not available, right? Or the video is corrupted, video is not available, or the frames are over. In that situation, the red becomes false. So red is a very good variable that we can use for keeping track of the number of, or the, like we can check whether the source is available, or we can check whether all the files are read or not, right? And one last thing. So if you run this, like you are not right. Right. So you can't now, if you run this, you can't close the video in between. See, can you? Can you? No, it will be opened again, right? Why? There's a loop and it will be opened again and again. So you have to definitely wait until the end, right? So what we can do, like, let's say if you want to break the, I mean, if you want to close the video in between, right? Then what we can do, we can use this wait key, right? You know that from the wait key, we can keep a track of the key we pressed, right? We are going to press, right? We press simply. So then we can say, okay, I'm going to do something like this. If the key is equals to 27, I'm going to break the loop, right? So now what will happen? Again, if someone press the escape key, why escape key? 27 is the ASCII value of escape. Now you can use any key you like, right? You can use any key you like, right? Right now I'm using 27, why 27 is the escape key, right? So that's something I like, right? So then what will happen? Now what will happen, right? When you press the escape key, it breaks in bit, I mean, in middle of the video, it's going to close the video, right? Why? When we press the escape key, again, this breaks, so go and destroy the windows, right? Got it? So that's something that I wanted to highlight again. Right? Got it? Right? So the other thing, like if you want to, like now, I mean, you can think many applications, right? Think of many applications. Now, let's say that we want to press a particular key and we want to capture image, right? If key is like, let's say, I'm going to check the C character. C is 99, right? So, okay. I'm going to get 99, right? So if someone press 99, see, if someone press 99, I'm going to right, save a particular c.imwrite. I'm going to save this image, right? So sample image .jpg. So that's the path and the name, and then I'm going to save the image, right? So now what will happen? Let's see. So this is my default location, right? So the image will be saved here, not here, but here. So let's see. I'm going to run it. Then I'm going to press a key. Press C. Press C. See, the image is captured, right? Right. So very simple things, right? So nothing, no big deal, right? I just, you know, what happens is like when we press it, right? But there's a very simple issue with this, right? What? If you want to capture multiple images, what will happen, right? The same image will be replaced. Why? Huh? If you press C many times, right, the earlier image will get replaced and the new image will be saved, right? Why? Any idea? What I'm asking is like, okay, when you want to write the multiple images you want to save, let's say, right? So when you press C multiple times, the same image will be like the earlier image will get replaced and the new image will be saved, right? Correct? Yes. So why that issue arises is that the same image name we are using to save it, right? So same image name is used to save, right? So it's simple. What you can do is like you can have a count here, right? A count variable, like you can initialize the count to 0, and whenever the key is pressed, you can like put the count, like you have to convert it to a string and put the count and add it to the sample, right? Like this. So count, so it will be saved like 0 sample image, 1 sample image, and one thing you have to do is count equal count plus 1, right? So using this, what you can do is you can simply save it, right? So now each and every C, when you press the C key, right, the key, right, when you press the C button, what will happen? Always, right, the count increases by 1, so the frames won't get replaced. Let me press C for multiple times. I have pressed it for multiple times. Now let's see what has happened. Yes. So you can see I have multiple images captured, right? Right. So this is nothing but timing, like it's not a big deal, right? So I just wanted to show you that we can do something like this. Right, got it? Got the idea, right? Okay, good, right? So that's all about the video, right? And one last thing, how you can access cameras, right? How you can access cameras. So this is how we are going to do it. And if you have like a web camera, right? If you have a web camera, what you can do is, like if you are default camera, like if you are using a laptop, you have a default web camera, right? So in order to access it, you can put 0 here. You can put 0 here. So what happens whenever you put 0, right? Now, instead of now, earlier what was there was the path of a video file, right? So that's how we are going to read a video file, right? But if you want to access your default web camera, remove this path and just put 0 here. Then it will capture images from your web camera. Let's try to run it and see, right? I have my software-based camera, so I have different camera, right? That's at I mean, if you have multiple cameras, like multiple cameras in the sense, if you have connected like USB cameras, web cameras, right? So I have one web camera with me, right? So this is my web camera, right? So this is externally connected one, right? So if you have a default camera in your computer and also you have a separate externally connected USB camera, something like this, then what you can do is, now I'm having my PC, right? So I'm having a PC and my PC doesn't have a web camera, a default web camera. So I use that IV camera, software-based camera, to capture my my mobile phone camera, to get my mobile phone camera to this computer. So that's why that IV camera comes when I put 0 here. But don't worry, in your computer, if you have a default camera in your laptop, that will be shown when you put 0, right? Now I have a separately connected USB camera, right? So if you want to get that one, what you want to do is you have to put 1 here. 0 for the default camera, and any external camera you have, additional camera you have, if you have connected, you put 1 here, right? So then this is what it looks like from the camera, right? Got it? So the same thing, right? So this is how we are going to access cameras, USB cameras and web cameras, right? And also, if you have like a Wi-Fi camera, right? Wi-Fi camera or CCTV camera, what you have to do is you have to provide the IP address of the camera and the password and the username, right? So you have to refer the user manual, and user manual they says how to use the IP address and the username and the password. If you have a Wi-Fi camera, you can provide the username, IP address, everything of your camera and get your like for example like this, right? Then it will load the IP camera and you have to provide the username and password as well, right? Got it? So what if you have multiple cameras, right? So now I have two USB cameras. Let me get the other camera as well, right? So I have two USB cameras here with me, right? And this camera, another camera is there. Right? So the same type cameras, I have two cameras here, right? So now I have connected the other one as well. Now what I can do simply, right? What I can do simply, right? So you can get multiple camera feeds as well. So here I have source 1 and source 2, right? Source 1 and source 2. And what I'm going to do is infinite loop and I'm going to get the, so the same thing I have done twice, right? So that's what I have done, right? Then we have two cameras, 1 and 2 USB cameras. Then source 1 dot read, source 2 dot read. I'm going to get image 1 and image 2 as ret 1 and ret 2 as well. Either one of the cameras are false, that it's not available, I'm going to break it, right? Else I'm going to like show two frames, right? So image 1 and image 2, two frames are shown, right? So then the break and destroy, right? So let's run this and see what happens, right? So you can see the two cameras now. These are not like focus right? So these are two brands, so therefore you are not going to see the same kind of output, right? So anyway, you are going to see this two frames, right? So image 1 and image 2, right? Okay, so that's it. And here I have, like, so you can't use the same window name, right? So if you use the same window name, only one will be shown, right? Only one will be shown. So you have to have two window names, otherwise two windows won't be open, right? So the window name should be different if you have multiple windows, right? Got it? Okay, so that's how you are going to read the videos, right? Okay, so from this point, I'm going to stop the session for today, right? So what we are going to do from tomorrow onwards, I'm going to move on to now. You have the basic, like how to get a video, how to get how to get a video and how to load the image and how to do operations, and you have the basic idea with you, right? So now what I want you to do, right? So before coming on to the session tomorrow at 7 p.m., what I'm expecting from you, please go through the content that I have done today, right? And also, I need you to refer the modules. Now, if you are an expert or if you are quite familiar with Python programming, no need to go through the Python programming basic tutorial that you are going to provide, right? We are going to provide you. The Python basic tutorial is not necessary if you are expert or if you are quite familiar with Python, right? But I strongly recommend you to go through the Python modules tutorial. So that Python modules tutorial, we are going to discuss about like Python modules, basic Python modules, and NumPy, Matplotlib, those libraries. So those will be important for our future implementation. So I'm not going to go further from today. I mean today, since you haven't go through the Python modules tutorial, so I will give some time in the sense you have the time up to 7 p.m. tomorrow, right? So please go through those tutorials and try to understand the Python modules and NumPy and Matplotlib. So those tutorials will be there, and please cover them, right? If you are not familiar with Python as well, please go through the Python tutorial as well. But if you are familiar with Python, no need to go to the Python, but make sure that you have installed Jupyter Notebook and Anaconda Navigator and keep it in your computer installed, right? So if you want a guide on how to install the Python programming, how to install the Jupyter Notebook in your computer and how to work in Jupyter Notebook, refer the first video of the Python tutorial, the Python basic tutorial. You have to go through the first video. Then it explains how you can configure Jupyter Notebook, how to install it, and how to work on it, right? And please go through the Python modules as well. So from tomorrow onwards, we are going to go through the point operation, the pixel-wise operations, and then we have lots of works to do. And later, we are going to do this kind of application where we are going to detect coins, right? Coin detection, right? How we are going to detect a particular coin, right? So this is the project that we are going to do on tomorrow, right? Okay. So then after that also we have some other project as well in order to cover. So we will do that on tomorrow, right? So any question before winding up? So if you have any doubt, any concern, anything to be clarified, you can ask them now, or else you can leave. So we will come tomorrow, the same time, 7 p.m. and we will start the project and cover the sections, cover the theory parts. And tomorrow onwards, we are going to do, today is a kind of an introduction session. So we haven't done many things, right? So fundamentals, the basics we have covered, but tomorrow onwards, we are going to move on to real coding and real project, right? So in order to do that, I want you to prepare. So go through the content that we have covered today and also the Python modules tutorial. Please go through them and come tomorrow, right? Okay, so if there's any issues, you can ask them now, or else you can leave and we can meet tomorrow 7 p.m. right? Right. Yes, you have to use the same link. I forgot to mention, you have to use the same link to join tomorrow. The same link will be used. So it's a recurrent link. So throughout the 5 days, we use the same link. How long it will take to master machine learning, that depends on you, and I can't exactly say, Aravind, but the thing is, like we have a 5 days workshop, right? We have a 5 days workshop coming for machine learning, right? You will get notified. In that workshop, like we cover from very basics to very advanced concepts in machine learning, like supervised, unsupervised, classification, regression, clustering, principal component analysis, speech engineering, likewise, right? So that will be a good foundation for you, right? So by following that kind of code, I'm not saying that you are going to be a master, right? But you will get the basics and the fundamental machine learning concept covered, right? From there onwards, you have to do your own research. You have to apply those concepts that you are going to learn in this workshop into your practical applications, your project, right? So then you are going to learn it. So it's totally about like the project. So totally about the skill. I mean, skill in the sense you have to do projects and get that skill. So it's based on the experience. So it's something up to you whenever like you try and search and find and do things, right? You are going to master the thing, right? But within 5 days, in our course, within 5 days, we cover all the basics and all the concepts, all the fundamentals, everything in machine learning, right? So then onwards, you have to apply them into your projects, your codes, right? Your applications, then you are going to master it. do I need to learn all kinds of algorithm to master machine learning? No, not all, but there are few, right? I mean, few in the sense, you need to know what is supervised machine learning, what is unsupervised machine learning, what is reinforcement learning, and what is classification, what is regression, what is game, what is clustering. Likewise, there are fundamental topics that you need to be aware, like feature engineering. So after going through them, then only you can what is there in machine learning, right? So from there onwards, you can do your own work and you can master it. Right. Anyway, I will provide you, right? I will provide you, as I mentioned in the first, the fifth day, right? So you will get to know about machine learning. I mean, the basic and the applications of machine learning and the basic topics, right? So you'll get to know about fifth day. So then you will get a better understanding. Then the later course, we will cover like a full machine learning course. We will cover all the theories you want, right? Okay. So there's another suggestion. Can you please provide resources tutorial for using hardware like Raspberry Pi and integrated camera and then do computer vision? Would be really beneficial for industry internships and jobs. So it's possible, please do consider. Sure, Justin, I will consider that. And also I have some examples, so I will provide you them as well, and tutorials, recommended tutorials. I will provide you them. If you can remind me tomorrow, right? So I will prepare it today and I will provide it tomorrow, right? Do you provide any internship after the course? No, not yet, but we are looking forward to that, right? So due to this COVID-19 pandemic, we were planning to do that earlier, but within the COVID-19 pandemic, and it was quite hard to find these internships, but we are looking forward to that. And if we are going to do that, there will be a kind of evaluation criteria, and you will have to face some exams or some tests, and we will select best students from you. Then probably we are going to provide internships, but unfortunately currently no, right? But we are looking forward to that, and we will let you know if there is any update, right? Yeah, there's a question. In Raspberry Pi, do we need to install OpenCV Python module directly or some small module of OpenCV? No. The thing is, in early versions, installing OpenCV was a huge mess, right? So it took like 4 hours to install OpenCV in Raspberry Pi, but it's not like that now, right? So now you can simply install Raspberry OpenCV. Earlier it was a huge mess, and we have like spent 4 hours and we have to do it multiple times, and in order to get Raspberry Pi installed in OpenCV installed in Raspberry Pi. But now it's not. You can install OpenCV similar to installing OpenCV in Windows, right? So no, that's also I think these are yes, there are some dependencies that you need to install, right? Yeah. Right. Yeah, there are some dependencies and some work that you need to do, but it won't take that much time. Earlier it was a huge mess, but you can follow a simple tutorial like this and install it, right? At least you have to have like 8 GB or 16. I recommend 16 GB chip to install OpenCV in Raspberry Pi. Okay, right. So then thank you everyone, right? So we'll move through the course and right, get more knowledge. So thank you everyone. And I hope every one of you will be there tomorrow, and hope we can do 2 projects tomorrow and try to finish as much as possible. So go through the tutorial, modules tutorial, and also go through the content that we covered today, right? So thank you everyone and good night.